Hello, ladies and gentlemen. Welcome back. Glad you could make it. I'd like to welcome you back to our channel. I'm Mr. Thompson, and it is our job to show you the bow ties are cool and math is fun. Let's go ahead and get rolling with today's lesson on reflections. Now, we're talking about reflections. The biggest thing that we need to keep in mind with reflections is that figure, that point, whatever it is going to reflect over a line, and the points, the figure moves equidistant and perpendicular to our line of reflection. Most important part, equidistant and perpendicular. Equidistant and perpendicular to the line of reflection. Ladies and gentlemen, example 1. We're going to go ahead and reflect over either the x-axis or the y-axis. Now, this is one of those ones that actually has a mapping that goes with it. So if we start with our pre-image and we go ahead and reflect it over the x-axis, that horizontal axis, what's going to happen is that image is going to go from, in this case, quadrant 4, and it's going to flip up into quadrant 1. Going to flip over the x-axis. And notice that when we flip that, the orientation changes. It flips upside down. Now, when we go to do the mapping for this, xy is going to map to. Notice all of our y coordinates changed because it flipped. So it maps to x, comma, -1. Now we flip over the y-axis. Back here at our pre-image again in quadrant 4, flipping over the y-axis. That's going to take it all the way across the coordinate grid, across the y-axis. And notice now, all my x-coordinates are negative. They are the opposite. And you can see that image has turned around. The orientation has changed. It's flipped left to right. This one's going to map to y equals, excuse me, let me try that again. XY maps to. XY is going to map to x, comma, -y. The last one that we've got, that we have a mapping for that works easily, is when we're flipping over the line. Y equals x. That's also called the line of inverse. Y equals x is the line of inverse. And what happens is that takes your x and y coordinates and flips them. Flips your x and y coordinates. So they end up looking like xy maps to yx. Xy maps to yx. The line of inverse, it flips them. Ladies and gentlemen, it's now time for practice problem number 1. Ladies and gentlemen, problem number 2. In this case, we're going to be reflecting over a line that's not an x-axis, not a y-axis, not the line of inverse, but it is nonetheless still either a vertical or horizontal line. So in this case, our instructions say we're going to go ahead and reflect this figure ABC. We're going to reflect it over the line x equals -1. So it's going to be a vertical line going through x equals -1. Now, as you notice, I've got points on both sides. Oops, there we go, because we got 2 on one side, 1 on the other. I got points on both sides of my line of reflection. So what's going to happen is that point A is moving one direction, B and C are moving the other direction. It's actually going to spin right almost on its location, kind of almost on its center. That x equals -1 doesn't go exactly through the center of the triangle, but it's pretty close. And basically, ladies and gentlemen, the best way to do this, reflecting over a line x equals -1, you just got to start dancing. You just got to count and move, 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 boom, boom, boom. So we're going to look at that A term, and we're going to see, okay, how far is it from A to our line of reflection? We count over 1, 2, line of reflection. So guess what? We're going to move that same distance past the line of reflection. 1, 2 more. Past the line of reflection. Then we go ahead and plot R A prime. we look at B. Go ahead and look at B. Figure out, okay, count, move, count, move, count, move. How far is it to get to a line of reflection? It's like it's about 3 points. So from the line of reflection to B prime, count, move, count, move, count, move. All right, there we go. All right, we are at our new B prime. Same thing with C. I'll spare you any more dancing. Just count and move. 5 points to the line of reflection. From line of reflection to our new C prime, another 5 units. Go ahead and plot in your new points. Draw the lines to connect, and you're set. When you're reflecting over a line that's not an x-axis or a y-axis, you don't exactly have a mapping that works every time. But count and move works. Ladies and gentlemen, it's now time for practice problem 2. All right, ladies and gentlemen, practice problem number 3. This is the one that's given most people the biggest amount of heartburn because we're reflecting over a line that's not vertical, not horizontal, not x-axis, not y-axis. There's no nice mapping. It's reflecting over some other line that's in the form of y equals mx plus b, your slope-intercept form. And the nice part about it being in slope-intercept form, you know what the slope is, so you can work from that slope, finding your opposite reciprocal, because you know your move has to be perpendicular to that slope of your line of reflection. So in this case, we're reflecting over the line y equals 2x minus 2. So you got our y-intercept at -2. We got a slope at 2. Boom, boom, boom. Here's our line of reflection. We've got figure ABC, and we're going to reflect it over that line. Now, what we're going to do is from each point, I'm going to go ahead and draw a line at a slope that's I'm going to draw a line using the slope that's the opposite reciprocal. So if my line of reflection's got a slope at 2, I'm going to go and draw a line -1/2. So I'll go ahead and draw the line there, -1/2, and do that 3 times. Now, we said that it moves opposite and perpendicular. I'm sorry, I said opposite. I meant equidistant. It moves equidistant. They're the same distance. The same distance. Equidistant and perpendicular. So I'm going to figure out what is my distance from C to my line of reflection. I'm going to do a little Pythagorean theorem here. It's like that's about square root of 5. Or you can count down 1/2. That'll work too. Equidistant says that's the square root of 5. Square root of 5 over 2rc prime. Now we're doing B. That's a little harder. Okay, count down 3, count over. That looks like it's about 6. So 3 squared is 9, 6 squared is 36. Add that up. That's 45. Square root of 45. Big, long, ugly decimal, something just shy of 7. I think I'm just going to go ahead and call that 3 rad 5. 3 square roots of 5 is going to be our distance there. So equidistant. 3 square roots of 5 on the other side. Nice part about down here at A, down 3/6, it's that same pattern. 3 square roots of 5 to the line of reflection. 3 square roots of 5 to our point. Done and done. Reflect the points. Go ahead and draw them in. And label them. Ladies and gentlemen, find your slope, find your distance. That's the best way to reflect over a line in the form of y equals mx plus b. Ladies and gentlemen, thank you for watching today's video on reflections, both over x and y axis, horizontal and vertical lines, and those lines in the form of y equals mx plus b. Once again, please subscribe to this channel so that you can get the updates of when I create new videos to help you with your math course. And as always, I hope you have a fantastic rest of your day. Now it's time for practice problem number